So gases, a funny combination in the A-level specs of a little bit of physics that you have to know, but presumably much of that bleeds in from the GCSE, and then also looking at it from the perspective of stoichiometry, of the involvement of gases in chemical reactions and the special treatment associated with those. Now, of course, we did a lot of stoichiometry back in the stoichiometry module that included these gases, so much of that is just going to be repetition here, but it merits being repeated here. So anyway, starting off with the gas laws. So question 1, final volume, 2.4 liters of gas heated from blah, blah, blah. I don't believe in memorizing tons of formulas. I prefer that we think it through. So let's see what we've got here. We've got constant pressure, we're changing the temperature, and that will of course change the volume according to Charles' law. Charles' law says that when the temperature goes up, as it does here, 50 to 200, the volume will go up. So our final volume is going to be bigger than 2.4 litres. Now, of course, absolutely crucial when we're dealing with gases that the only temperature unit that we use is Kelvin. And so in order to set these ratios up, which is where we're going to want to multiply the 2.4 by a bigger ratio as the temperature goes up, we have to make sure that we have the temperature in Kelvin. So 50 becomes 273 plus 50 is 323, and 200 becomes 473 Kelvin. So new volume is the old volume multiplied by that ratio of the temperatures, the bigger number on top, 473 over 323, because we know that our final volume, the new volume, is going to be bigger than the old volume. So pop in that old volume, 2.4, and we get that the new volume, 3.51. Same idea with a twist. Gas sample in a flexible container, so the volume can change. Constant pressure, temperature increases. So change temperature, see what happens to the volume. That's a Charles' law problem. Because we increase the temperature, the volume will also increase. By how much? Well, we set up a little ratio that has the bigger number on top of the temperatures. And of course, it's not 25 and 75 Celsius, but it is 298 and 348 Kelvin. So the new volume will be the old volume multiplied by the ratio with the bigger number on top, 348 over 298. Pop in, the old volume was 4.2 cubic meters, so the new volume is going to be 4.2 times 348 over 298, which is 4.9 cubic meters. Now, that would be the answer in many cases, except of course finish the question. What is the change in volume due to the temperature increase? Well, the old volume was 4.2, the new volume was 4.9, thus the change in volume, 0.7 cubic meters. So a sample of gas initially at 720 kilopascal and 50 degrees Celsius, heated to 100 degrees Celsius, a container of constant volume. So a bit different now. We're changing the temperature. We want to see what happens to the pressure. So that is, of course, known as Gay-Lussac's law. Now, according to Gay-Lussac, pressure and temperature are proportional. So in this case, the temperature is going up, so the pressure will go up. So we need to use a ratio of the temperatures that has the bigger number on top. New pressure going to be the old pressure multiplied by the ratio of temperatures. Just in case you've forgotten, I put it in here, and 100 over 50 would give you the wrong answer because that's Celsius. We of course need to convert to Kelvin, and so it's actually 373 over 323. The old pressure was 720 kilopascal multiplied by that ratio of the temperatures. That's going to increase the pressure. And we get the new pressure, 831 kilopascals. Ideal gas, here's a volume at a temperature and a pressure. What's the new volume at a different temperature and a different pressure? So now this is where we have to combine laws. We start off with Boyle's law. Boyle says if the pressure goes up, as it does here, from 1.2 to 3.6, the volume goes down. If we want the volume going down, we need a pressure ratio that has the smaller number on top. So therefore the new volume is the old volume times the smaller pressure ratio right there. Now of course that's not the end of it, because we also changed the temperature. So Charles' law, the temperature increased from 25 to 75, so therefore the volume will go up. But of course we can't use 25 Celsius and 75 Celsius. We have to convert those to Kelvin. And so putting that in then, bigger number on top for the temperatures because the volume goes up. 75 is 348, 25 is 298. So there's the pressure ratio that will decrease things because when pressure goes up, volume goes down. There's the temperature ratio that will increase things because as temperature goes up, volume goes up. Put it all together with the original volume, 0.5 litres, and we find that the new volume, 0.195 litres. In other words, the pressure increase, thus decrease in the volume, is more significant than the increased temperature would increase the volume.